Hi, my name is Carolina. Before we start in the nephron, we first should outline the functions of the nephron. First, we have filtration. It's where the formation of filtrate is made in the Bowman's capsule. Further, we'll talk more about the Bowman's capsule. It's where waste, nutrients, water, protein move from the blood into the nephron. Next, it's reabsorption. That's where nutrients, ions, water move from the filtrate back into the blood. 3 is secretion. That's where ions, waste, toxins move from the blood into the filtrate. These are 3 important steps that occur in the nephron. First, we're going to do the nephron structure. This is the Bowman's capsule. The Bowman's capsule is the site of filtration and the formation of filtrate. Then we have the proximal convoluted tube. The proximal convoluted tube is mostly reabsorption. Next, we have the loop of Henle. The loop of Henle is also in charge of reabsorption. Then we have the distal convoluted tube. The distal convoluted tube is the site of secretion and reabsorption. Then we have the collecting duct. This carries urine to the renal pelvis and is also in charge of reabsorption and secretion. Now let's talk specifically about what happens at each step in the nephron. First, blood from the renal artery goes into the Bowman's capsule. At the Bowman's capsule, filtrate is produced. Blood pressure forces small solutes, water, ions from the blood into the capsule. Next is the proximal convoluted tube. This is where most of reabsorption occurs. This includes water, ions, and all organic nutrients. Third is the loop of Henle. This is where reabsorption of the water occurs at the descending limb, which would be this one, and reabsorption of Na and Cl occur at the ascending limb, which would be this one, the thick, versus the thin, where water is reabsorbed. And the thick is where Na and Cl ions are reabsorbed. Next, we have the distal convoluted tube. Here, secretions of ions, acids, drugs, toxins, this is where that occurs, the secretion. There's also variable reabsorption of water and sodium. Next, we have the collecting duct. This is variable reabsorption. This could include water, potassium, sodium, hydrogen, HCO3, and other variable secretions such as water, potassium, sodium, hydrogen, and HCO3, depending on what the body needs. Last, we have urine content. Urine is made up of water, urea, creatine, uric acid, and other various ions. This whole process occurs in order to produce urine. Now let's talk about other vessels of the nephron. First, we have the afferent arterioles, which is where the blood comes in to deposit into the Bowman's capsule. Then we have the efferent arterioles. This is where the blood exits the Bowman's capsule. Then we have the peritubular capillaries, which surround cortical parts of the proximal and the distal convoluted tubes, while the vesa recta goes into the medulla to approach the loop of Henle. The higher osmolarity of the blood in the peritubular capillaries creates an osmotic pressure which causes the uptake of water. This is critical for the reabsorption of water back into the blood. This also has a countercurrent multiplier, which is critical also for the reabsorption of water and other ions back into the blood. Last, let's talk about 2 important hormones. One is antidiuretic hormone, which can also be thought of as always drilling holes. Antidiuretic hormone stimulates the insertion of aquaporins, which are water channels that return water back into the blood. The next is aldosterone. Aldosterone increases the reabsorption of sodium and water levels both at the collecting ducts and at the distal convoluted tube. Both are stimulated by the increase of angiotensin II. Both return GFR back to normal, and both also increase blood volume. Now you might be wondering how both of these affect urine production. Urine production is decreased by both of these because both increase the reabsorption of water back into the blood, therefore decrease urine output.